Alright, hello, good morning everyone. Okay, today's lesson we are going to talk about numerical integration, right? And in numerical integration in mathematics specialists, we are going to do 3 rules. The first is what we call the midpoint rule, but where you are going to use rectangles to approximate area. And the second would be the trapezoidal rule or the trapezium rule, where you are going to use trapeziums to approximate area. And the last one, Simpson's rule, will be using 2 curves. Alright, so when do we use numerical integration? Numerical integration shouldn't only be used if the question were to ask you for an approximated answer, or the question asks you for an approximation. If you want to have accurate or exact area, that is when you don't do numerical but you do integration as it is. Okay, alright, so let's look at the first numerical integration, which is the midpoint rule. Okay, please bear in mind that in methods you have learned to use rectangles to approximate area, isn't it? And what are the types of rectangles that you can use? You can actually go with the left side rectangle, the right side rectangle, and also the centered rectangle, remember? So which one is the most accurate? Like, you know, if I were to compare these 3 types of rectangles, for sure it is the centered rectangle, because it over and underestimate accordingly, and hence area that you got will be closer to the exact. Alright, so midpoint rule, it's simply the centered rectangle approximation. Okay, so what is the midpoint again? Okay, let's look at one example. Alright, I said over, okay, I've written on the board, find approximation for the definite integral for a function fx ln 5x from x equals to 2 to x equals to 6 by calculating the areas of strips with 0.5 units wide. Yeah, so how do we ask our questions usually in numerical integration? It's either I provide you with the width, and for this case it is 0.5 units, or I tell you how many strips, okay, to divide your area into for you to approximate. Okay, so for this particular example it is with the width. Alright, so width over here, okay, how then do we tell how many strips? Okay, we're gonna go 6 minus 2. Why 6 minus 2? Because we wanted to approximate the area from x equals to 2 to x equals to 6, hence it is 6 minus 2 divided by n, and n is the number of strips. Alright, so since question has already told you that width is 0.5, which is half, you're going to go number of strips to be 8 lah. Okay, so how do I work on this one? What I've done on the board was, okay, I drew the graph of y equals to ln 5x, and it is actually a curve like this. So if these 8 strips are going to divide my area into, you are going to get 8 rectangles like that lah. 1, 2, 3, 4, 5, 6, 7, 8. Right, so how then do I approximate? Bear in mind I'm going to make use of the midpoints. Alright, so to tell the area of one rectangle, it is simply width, and width for this case would be 0.5 multiplied by length. Am I correct? So what length are we talking about? We are simply talking about the value of fx when x is equals to the midpoint. So with the first rectangle, midpoint would be 2.25. Yeah, so how can I tell my midpoints? Alright, bear in mind that my boundaries would be 2, 2.5, 3, 3.5, and accordingly. Why is it 0.5 apart? Is because width given to us is 0.5. Okay, so what then would the midpoint between 2 and 2.5 be? It would be 2.25. Okay, so if I were to look for area for each rectangle like that, that is when I'll form something like this. Okay, I'm going to go first rectangle, it is the width 0.5 multiplied by length, and it should be f 2.25, and then the next rectangle, the second rectangle, it is the width of 0.5, and then okay, a length of f 2.75, and accordingly till the 8th rectangle where you're going to have 0.5 multiplied by f 5.75. So can I form a summation with this one? Definitely can. Okay, and what sort of summation can I form over here? Pretty obvious that I have got the same width all over. It is 0.5, hence I'm going to leave my 0.5 in front. So what summation do I have then at the back? It should be f 2.25 plus f 2.75 plus f 3.25 plus f 3.75, and accordingly up until plus f 5.75. Alright, so how many rectangles again am I looking at? I'm looking at 8 rectangles, okay, 8 strips, because width was 0.5. Okay, so if that is what I got, okay, I'm going to go summation I equals to 0 up until 7. Why 0 to 7? Because 0 to 7 give me 8. Okay, give me 8 strips, alright? So then I'm going to go f2.25 because the first term that I got over here is f2.25 plus by 0.5i because every midpoint would be 0.5 units apart. Okay, so if this is what I got, plug this into the case calculator and that is when you will get the approximated area for the integral ln 5x for x is from 2 to 6. Okay, so that is midpoint. Alright, so what then about trapezium and trapezoidal rule? Okay, note that this is definitely more accurate as compared to midpoint rule because the tendency of you overestimating and underestimating would be lower. Okay, so what question was it that we're going to discuss? So find an approximation for the integral of exponent x. X is from -2 to 2 using 8 strips. So some of you might say, teacher, this one I can integrate it just like that, isn't it? You are correct. Okay, you can actually integrate it just like that to get an accurate or an exact answer, but what I wanted over here is an approximation. Hence, you have no choice but to do numerical integration. So what keywords to look for in exam? You will either need to look for numerical integration or the word approximate or the word approximation. Right? So this one says 8 strips. See, if it is 8 strips that I've given to you, I will now have to look for my width lah. Okay, so what is my width? It is simply 2 minus by -2 divided by 8 strips. The same formula applies, which is equivalent to half. Hence, every trapezium that I've got will be 0.5 apart or half units apart. Okay, so what then is the area of a trapezium? Let's recall on the area of trapezium. It is simply half multiplied by width multiplied by a plus b. Okay, so looking at it, okay, I've drawn y equals to exponent x on the board and these are the 8 trapeziums. Okay, so what are areas if I were to list every single trapezium down? I'm going to go with the first trapezium and it is simply width 0.5 divided by 2 multiplied by f -2 plus f -1.5 because I needed the length of this, I needed the length of that. Am I correct? So if I were to go with the second trapezium, it will now be 0.5 over 2 f -1.5 f -1 and accordingly you're going to do. So what sort of pattern do I see over here? The first term appear once, f -2. The second term appear twice. And then the third also twice. The fourth, the fifth, up until the last, you're going to have one term again. And the second last will be appearing twice again. So if this is the pattern that I see, what sort of summation can I be forming? What is common is 0.5 over 2. So I'm going to put 0.5 over 2. The first term, I'm going to go f -2. The second, the third, the fourth, the fifth, the sixth, and the seventh. I'm going to put, and the eighth, sorry, I'm going to have 2 with the summation because it is 2 units, okay, and the last term will be f2 lah. So what am I working with this time? I'm actually working with boundaries. If I were to look at 8 strips, 1, 2, 3, 4, 5, 6, 7, 8. How many boundaries do I actually have? It should be 9 boundaries because 1, 2, 3, 4, 5, 6, 7, 8, 9. So if it is 9 boundaries that we are talking about, I have had the first boundary written, I have had the last boundary written. Then how many then do I have left with my boundaries? For sure, 7 because 9 minus 2 is a 7. So if it is 7 that I'm going to look at, I'm going to go 2 times summation I equals to 0 up until 6 because 0 to 6 give me 7 boundaries. Okay, so it is f -2 that I've written. The next term must be f -1.5. Hence, I'm going to put here f in bracket -1.5 plus by 0.5 I. And why is this correct? Is because if I were to sub I to be 0 over here, that is when I'll get 2f -1.5. If I were to sub I to be equivalent to 1, that is when I get 2 times f -1 and accordingly. Alright? So use your CAS calculator and you will see answer to be 7.40421. Alright? So is there another way of writing my summation? Yes, there is actually another way. And is there a need for you to actually know both or to write both in the exam? There is no need for both to be presented in the exam, you see. So know either one of these and you are good. Okay, so what is with the second one? The second one, I work with strips. Yeah, so strips, I'm going to go 0.5 over 2 again because that is the common term. With the first strip, I'm going to go f negative 2 plus f negative 1.5, am I correct? So it is f negative 2 and f negative 1.5 that I got to write. And why is it adding a 0.5i? It's because it is always like, you know, every, what do I call, a boundary that you see will be 0.5 units apart. Okay, so how many strips do I then am I working with? I'm working with 8 strips, and hence I equals to 0 up until 7. Okay, and accordingly you plug into your CAS calculator, and that is when you will get the answer 7.40421.